Okay, this is a video to show you the solutions for the problems on quiz number 5. You can look at your quiz while you watch the video or go back and forth between the two to try to help learn what you did wrong and how you could do the problem in the future. Then you'll be one step closer to retaking. All right, number 1 says, at your new school job, you're earning $9 per hour. You're saving up to purchase a new iPhone. When you already have $35 saved, or you already have $35 saved, write an equation to represent the amount of money you have saved in terms of the number of hours you have worked. And we're going to try to model it in the y equals mx plus b format, where the m is your rate or your slope, and the b is your y-intercept, which for word problems is usually a starting point. So with that regard, we just said that you already have $35 saved. So that's my starting point. We also said that you were earning $9 per hour. So per is a keyword you look for rate. So $9 per hour. Then the question says to use S in terms of the number of hours you worked H. So the total amount of money you have saved is going to be 9 times the number of hours you work. So 9 times 0 if you work 0 hours, 9 times 1 if you work 1 hour, 9 times 2 if you work 2 hours. So 9 times H for any hours, plus the amount of money you started with. So if you work 0 hours, you'll have $35. If you work 1 hour, you'll have 1 times 9 is 9, plus 35 is $44. And you could have also written it y equals 9x plus 35, or some combination of those. Some of you guys used s and x, or y and h, but both of those are okay. And that's number 1. Number 2, for English class, you're keeping track of how many words you have typed for an essay. You're able to type 33 words per minute. So there's that per word for rate. Okay, words per minute, that's my rate. When you started working, when you got started, you already had some written. So you had some of the essay written. So my starting point, we don't know. Just some words. And we want to find that. The other thing they told you is that after working 15 minutes, you've typed 545 words. So that's 2 pieces of information regarding minutes and words. Write an equation that represents the number of words written, W, in terms of the number of minutes, T, you've been typing. So the 15 minutes and 545 words is a point of information. Spent 15 minutes typing. You've typed 545 words. And we have our rate. So if we use our equation with a rate and a starting point, y equals mx plus b, we can plug in x and y for our minutes and our words, and we have our rate up there in green, and we can solve for the starting point. Because right now we don't know the starting point. So you didn't type all 545 words in 15 minutes. That's too big. You're only doing 33 words a minute, but you total have 545. So we'll plug in our numbers. The y is 545. 545 equals my rate, 33 words per minute, times the number of minutes, so times 15 minutes, plus whatever I started with, b. I don't know what that is. Starting point is b. So I'll use my calculator. 33 times 15 is 495. So So this 545 minutes is equal to 495 minutes plus my starting point. So I could plug in random numbers to try to get that. Or I could subtract 495 on both sides. That's going to give me 50 equals B. So I actually started with 50 words, and then I typed for 15 minutes. So my equation, if I use W in terms of T, is going to say the total number of words that I'm writing is going to be given by 33 words per minute, 33T, plus the 50 words I started with. Or again, you could use Y and X, that's fine. Y equals 33 words per minute plus the 50 words I started with. For number 3, write a linear equation that models the information given. Tom is going to a fair in town and wants to eat lunch. Hot dogs cost $2 each and cheeseburgers cost $3 each. Write an equation that represents the possible combinations of how many of each he can buy for all of his $12. Define your variables that you are using. This means tell me what letter you're using and what it represents. So if you use X, tell me what X represents. Okay, so for this type of problem, we have different information. We have a total of $12, and we have two rates. We have a $2 rate for hot dogs, $2 each, and we have a $3 rate for cheeseburgers. Whenever you have two rates and a total, we're actually going to use a standard form equation. Because we don't have a single rate and a starting point, we have two rates and a total. My total is what it's equal to by itself. And A and B represent the two rates. So if I let X equal the number of hot dogs that I can buy, and I let Y equal the number of cheeseburgers I can buy, then my equation would be $2 for each hot dog, 2 times X, $2 times the number of hot dogs, plus $3 times the number of cheeseburgers equals my total. And I could have also done something like 2H plus 3C equals 12. And then just said H is the number of hot dogs, C is the number of cheeseburgers. Number 4, write a linear equation that models this information. After 2 months of a gym membership, you've spent $165, and after 5 months, you've spent $300. Write an equation that represents the relationship between months and total spent. So we don't have a total. We don't have a starting point. We don't have two rates. And we don't have a single rate. So everything we've done so far, we don't have. Now, if I'm at a gym membership, which one of these makes more sense? Would it make more sense to have two different rates at the gym membership and a total? Or would it make more sense to have one rate at a gym membership, like you're paying a fee per month, and then a starting point, like you have to pay so much to join the gym? Okay, I think that second option makes more sense. So even though I don't have a starting point or a rate, I want to find them. If I'm going to be finding a starting point and a rate, I'm going to be using the equation y equals mx plus b. Because again, my starting point is the b value, and my rate is the m. Now, what did they actually give me then? They gave me two pieces of information that I can arrange into the shape of 2 points. So for 2 months, it cost $165. For 5 months, I spent $300. When I want to find a rate, we have a formula. My rate formula is equal to the two y values subtracted, so the difference in the y values, divided by the difference in the x values. So 300 minus 165 over 5 minus 2, which is 135 divided by 3, which is 45. So my rate is $45 per month, because X is number of months. So now I just need my starting point. To find my starting point, when I have a rate, I'm going to choose one of the points and plug in to my formula. So y equals mx plus b. 165 equals 45 times 2 plus b. 165 equals 90 plus b. And if I subtract 90 on both sides, I'll get 75 equals b. So my equation will be y equals 45x plus 75. I have a startup initial cost of joining the gym of $75, and it's going to cost me $45 each month. Number 5. The graph below shows the average number of gallons of milk a family drinks per week. Select the equation that best models the data. Use the highlighter tool to tell me which is the correct answer. You can also use the highlighter tool to graph if you need to. So there is a positive trend to the graph, which means that choice B is not an option because this has a negative slope. If I look to see if there's anything else obvious that I can work with, it appears that for A, the y-intercept is 3, which is a little bit high. And I can graph it. I can graph the slope of 2/3. So up 2 boxes over 3 boxes, up 2 boxes over 3 boxes. And that's not a good line of fit because everything on that line is above my set of data. If I look at choice C, y equals 4x, it means its starting point, since there's no number there, is 0. And if I go up 4 over 1, that's my line. And that doesn't look good either. So that leaves choice D. If you graph choice D, y equals x, so I have a slope of 1, and I start at 0. Out of the choices, that's my line of best fit. For number 6, we want to choose the best estimate of the correlation value. Because the graph is going down, it's decreasing, I have to have a negative slope. So if I'm looking at a number line of negative numbers, here's 0, Here's negative 1. Okay, negative 0.5, negative 0.25, negative 0.75. At the end, I'm going to have a perfect line where every single point is on my line. It's a 100% correlation. At 0, I'm going to have no line at all that could be drawn. So if I look at these options, negative 0.99 is very, very close to negative 1, which means that all the points would have to be extremely close to the line. This doesn't work because it's too perfect. Or another way to say that is that the points are not close enough to be considered a straight line. Negative 0.23 is pretty close to no line. It's a pretty small correlation. That's not good. So the best guess is a stronger negative number like 0.75, but not too strong. Number 7. About half the people on the quiz got this problem wrong. I actually have highlighted the right answer. We have a negative line going down, so it's not going to be the bottom two choices. The remaining two choices have the same y-intercept of 170. And so which equation works best? A lot of students chose y equals negative 2/3 x plus 170 because you may have looked at this and thought, if I go down about 2 boxes and over about 3 boxes, I get this point. Down about 2 boxes, over about 3 boxes, down about 2 boxes, over about 3 boxes. So down 2 boxes, over 3 boxes is a correct slope, but that's not what your slope says. Your slope in this equation says negative 2 over 3. If you go down 2 boxes, you're going 40 units. It's going up by 20s, so you're going down 40. If you go over 3 boxes, you're going over 1.5. If you take your calculator and you do 40 divided by 1.5, you get 26.7, which is really close to negative 25. Now, what we did in class the day of the quiz, as we extended how we were learning differently, the new concept from class that day was this. When your scale, which tells you how much each box is, when your scale is different, so the vertical scale is going 20, 40, 60, 80, 100, 120. So by 20s. And the horizontal scale is going 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. When your scale is different, you should test a point. So when your scale is different, you need to test a point. And this is what this looks like. If I'm looking at these two equations, this one in blue and this one in red, I want to see which one's right. I can pick any number on my graph, like 3. And I can plug the number 3 into the equation for x. Let x equal 3. For my top equation, that's negative 25 times 3 plus 170, which is negative 75 plus 170 which is 95. So the point 3 gives me 95. If I try to graph that, it's going to be right on the line. So I do that for the other option, negative 2/3 times 3 plus 170. I'm going to get 168. So when I plugged in 3, I got 168. So 3 and 168 is nowhere close to the data. So when you have a different scale, you need to test a point.